Hello, everyone, and thank you for joining us for this episode of Threat Talk. I'm your host, Bob Hansmann, and today we are once again diving into one of the less talked about areas of cybersecurity, malvertising. Now, it could be considered the web equivalent of email's phishing, and it remains a common malware delivery mechanism, but it seems to get a lot less press. However, the success for a threat actor typically requires a lot of work building a network. Perhaps that's why they still prefer phishing. It's a lot easier to do. But building this network is key to their success because it has to function while remaining fairly undetected. But they can be detected. And we have with us today Chance Tudor, one of the threat hunters in the Infoblox Threat Research Labs. Thanks for joining us, Chance.
Yeah, thank you, Bob. It's a pleasure to be here.
And the reason we've invited him is because he just recently uncovered a malvertising network that had, doing what normal malvertising networks do, but it also had some pretty interesting features. But before we get into that, since malvertising isn't something a lot of people talk about, let's kind of review what is malvertising and what does it do.
Sure, I think that's a good place to start. So malvertising is a fancy name. It's a shortening for malicious advertising. The goal is for malvertisements to draw up malware, potentially unwanted programs, deliver scams, and in the end, garner profit for the actor behind the malvertising campaign. Drive-by downloads are also possible. It's when you show up to a website and all of a sudden, in the background, no notification or anything, there's a malicious program that is downloaded to your device. A lot of times, these malvertisements also have callouts and alerts to catch the user's attention, to get them to actually click on this malicious advertisement. And they're intended to look legitimate, but more often than not, they are not, legitimate advertisements. They are
Well,
malicious.
the thing I think is really cool is that not only do they look legitimate, but they're being delivered most of the time by legitimate agencies. It's somebody who they create their fake ad and then they work with and sometimes even pay. I mean, these are businesses now. They will pay an agency to distribute their ad.
Yeah, that's right. And that's something that we did see with the Omnatour Malvertising network. Um, you have a case where you've got an actor. Everyone knows that internet ads make a lot of money. So, like you mentioned, there are these advertising campaigns or um, companies out there that are their whole goal is focused on internet advertisements. They don't care who buys advertising space from them or uses them because it's a two-way street there. They both make money in the end. It doesn't matter whether it's legitimately or if it's actually malvertising campaigns.
Yeah, they have no motivation to make sure that it's even a legitimate product. They don't care if they're
That's right.
advertising scams. Their job is to get clicks on the ad. And so
That's
they
right.
even help the bad guys. They give them advice and templates about, hey, we're seeing right now that this is the really, cool thing you ought to do in your ad to make it work better. So they're helping the bad guys kind of improve their attack technique.
Yeah, in a sense, that's true. They just have a plausible deniability, if you will. They can wipe their hands clean and say, well, it was just another customer. We didn't know what they were using us for, but sure, they wanted to pay us and we get money in the end. So yeah, we'll let them use us as their advertising company.
Well, and of course, a lot of companies before something becomes important, it has to be tied to something they're really worried about, and they may not even think about malvertising. But just like phishing emails, malvertising can deliver pretty much any kind of malware. It can deliver ransomware. It can deliver, those long, persistent kind of things. And in most cases, again, since they don't want the malvertising network to be discovered, the first thing they're going to introduce is hopefully going to be something subtle that won't set off alarms right away. Correct?
Yeah, yeah, that's definitely correct.
Now, the network that you just recently dug into and found is being called Omnatour, the Omnatour Malvertising Network. And you wrote a wonderful little cyber advisory. It's been published as a blog on the Infoblox site. Um, Now, how does this align with the typical model and how is it different? And how does this one stand out? But let's start with
Sure.
how does it align? I mean, imagine it's still doing fake ads.
Yeah, fake ads are there, but what's actually really funny is that the majority of the advertisements that I saw were related to antivirus software and ad blockers. Ironic, but uh, I did see. It seemed like the threat actor. It's more of an advanced threat actor when it comes to malvertisement specifically. I did see some legitimate advertisements sprinkled in, and it harkens back to that discussion that we just had. when you have this legitimate advertising company and a malicious threat actor and they're partnering, it doesn't necessarily mean that all of the advertisements are going to lead to a piece of malware being installed. So when I saw these somewhat legitimate advertisements still delivered in an annoying pop-up, redirects, push notification way, it led to the Norton.com website, which again is ironic because it's intended, it's a security product intended to prevent malware from running on your system, and yet you're getting this sprinkled in with fake ad blockers, malicious Chrome extensions, again, an ad blocker, which is important to note too, because McAfee just in a couple of days wrote a report about these 5 malicious Chrome extensions with over 1 million users that were actually exfiltrating sensitive user data. So you've got these malicious programs, being pushed to the user alongside something like Norton, which some people would call malware in and of itself, but I don't know.
Yeah, yeah. You're talking about malicious advertising. Some people think all advertising is malicious, but
Fair point.
but that comment you made about the uh, the fake apps that were on. I think these were on the Google Play Store, where they were turned out to be mining software. There's so many fake everythings, and that's the thing the bad guys do. What I thought was interesting though is that they aren't just showing their bad stuff. Like you said, they had a legitimate ad that went to a legitimate place. And I know that a lot of security tools, part of their, when they talk about machine learning and AI, um, signatures are still used because it's real easy and super fast to check a bunch of signatures and say, yes, this is a known thing.
Yep.
But then they get into this, okay, so now we've got something, it's kind of in this gray area. And they do kind of a pros and cons. What are the things that we see here that are like malicious apps? But they also go through and say, what are the things that we're seeing this do down this list that are like legitimate apps? I mean, only a legitimate app would link to a security site, and
Exactly.
so they
Yeah.
do those things to throw off your other defenses. And this is how they get through. I don't, we hadn't talked about this when we were planning this session today, but that's an important aspect, is that they are throwing in the legitimate stuff, and that makes it even harder to detect.
Absolutely, especially from a threat hunting perspective, when you're trying to map out the infrastructure, you can have we'll say you have one known malicious malvertising domain. You can find websites that have that malvertising domain, that little fingerprint, if you will. And when you say go into a VM and you try to actually explore that website yourself, you try to follow the trail, you analyze it with Wireshark, and you look for that DNS trail. When it ends at Norton or there's a redirect at Norton.com, all of a sudden it's like, well, I guess this isn't so malicious after all. It's a way to throw you off the trail.
Yeah, I remember when they started this, there was a piece of malware that it pretended to be a photograph. This was when in email you could change the extension of something. So it would say puppy.jpg, but it was actually an executable.
Yeah.
And when you ran it, it would take a look at the environment, and it would show you a picture of a puppy. And while it was showing you the picture of the puppy in the background, it would do other things. But if it determined that it was in some sort of a virtual environment, like in a sandbox or something like that, one of those really advanced security tools, well, it could tell when it was in a sandbox, in which case it would show the picture of the puppy and stop. And that's all it would do. So it would do, again, something legitimate, but avoid the negative things that might set off alarms. Now, so they get really crafty here, and they're using vulnerabilities and inspecting their environment. On this one here in particular, in your advisory, you mentioned that this was pretty much exclusively taking advantage of WordPress.
That's right. So the way that this all worked was an actor um, went out there and found, like you said, vulnerable WordPress sites. WordPress is very common because there are so many vulnerabilities. Once they identified these sites, they'd perform a cross-site scripting attack and inject a malicious script that would then load back in another script, right? So you've got this inline script calling out and returning another JavaScript. And that returned value is the adware script. So that's where the actual injection comes into play. And then you start to see all the malvertisements. One thing that I'd like to add on to what you were just talking about, that example with the puppy trying to hide and would stop in the VM, we did see that. In a sense, you could go to this website, right, in, say something like a virtualized environment. There are plenty of websites out there, like an AnyRun type of thing, where you can put in a URL, it'll go to a website, et cetera, et cetera. But if there was, in order for this attack chain to execute all the way through, there were checks throughout to make sure that there wasn't, say, a piece before missing. So if, there are plenty of domains being interspersed throughout this entire attack chain. If you pick out a domain from the middle of the attack chain, so not the initial WordPress vector and not the landing page, somewhere in between, and you go to visit that domain, you try to explore it, nothing will happen. It's completely benign. You can't actually get any data behind it because the attackers know that there are people out there that are going to try to identify this thread chain. And they know if you're in the middle of it, you're a researcher, you're trying to pick apart what they have going on in the background, they're not going to let you see any of that data. So in that sense, it is quite similar to that example that you mentioned.
That's cool. That's the redirect, which is a legitimate tool. Redirects is what people do on their websites all the time, where they'll create a page, but then they say, we need something easy for people to type in. So we're going to have, ourcompany.com/report, make it easy. So they don't have to do the /assets/docs/white paper/ they make it real short, but they just have it redirect to the page they want to. I do recall, it was about 10 years ago when that really got heavy, and there was a malware site that when they set it up, all of their initial little phishing email, because this was a phishing one, but the links would go to a site that, like you said, was benign, and that would redirect you somewhere else. And then that would redirect you. On average, it redirected the person through 7 different sites before it actually took them to the bad stuff. And again, that was because a lot of security tools that are supposed to check the URL and make it safe, they only check the first one or maybe the first 2 or 3. They didn't check the last one. And so they purposely did that to basically exhaust the way the security tool works. This security tool is designed to check 2 or 3, so we're going to go 4, that kind of thing. And wow, I wasn't aware that redirection was being used in here as well. They just bundled a whole bunch of evasive maneuvers on this thing.
They did, definitely. There was also like a usage of C2 servers. So there was JSON being passed back and forth between the local host, your machine, your browser, and the C2 server out somewhere else that allowed that communication. It allowed you to see if like the user agent or if the banner ID, the campaign ID actually matched, right? So when that remote adware script is loaded, information like that is passed back and forth. So that's where when you look at it in some sort of virtualized environment, it can tell that the banner ID or the campaign ID is stale. Say it's a domain that you found, or URL specifically that you found, maybe a week ago. So maybe that banner ID, that campaign ID, that user agent, it doesn't match, and the actor is able to sniff that out and doesn't give you what you as a threat hunter want. You want to be able to see all the steps involved, and the end goal is to find some source code, which I was thankfully able to do.
Yeah, and the thing here is, I want to keep reminding everybody, we're not even talking about the malware. We haven't even gotten to that point, because what it could deliver is different things. These are all the components just to deliver the malware. This is the whole network, the infrastructure, the multiple stages of evasion that are all embedded, that it has to get through all this, and then it will actually deliver the bad stuff, which I wanted to ask you, because one of the things this did was it modified browser. Was that part of the network, or was that part of the malware? Modifying the browser, I think that was part of just the network wanted to do that, right?
So by network here, we mean we use
The malvertising network, yeah.
Yeah, so that's our term for this. We found 9,900 domains, 170 IP addresses that they're all tied back to one actor, right? So we call that the network. So I guess you could say network and malware interchangeably, because the network is used to deliver that malware in a sense. So it was the actor, it was the network that through these AdWords scripts, right? So, WordPress, inline script, sends out to a remote server delivers an AdWords script back. That's where that push notification, that's how the browser settings were changed, right? So you're viewing this website and all of a sudden in the top left corner, you have, X website would like to send you push notifications you can accept or deny. Um, we talked about in the introduction how malvertising tries to get those call outs, tries to get the alerts, the user's attention. Most of the time, humans now are so used to push notifications. We like push notifications. So you're going to click accept. There's a pop up, sure, whatever, I'll click accept. That's where the browser settings are then modified. Once you click accept, then it's persistent. The malvertising network is able to send you push notifications, pop-ups, redirects, pop-unders, even if you're not in your browser. It'll show up, some like Windows now has a notification center, Mac OS does, even Linux has a notification center. If you're on your desktop, you're not even in your browser, you will still receive these push notifications with malvertisements. If you leave and go to a different site, you'll still receive push notifications because it's persistent, all because you clicked accept at that one stage.
Yeah, and I'm not sure how they did it specifically in this one, but I know that when they start doing pop-ups to get authorization to change a setting or to access something and do something that requires admin privileges or something like that, the pop-up doesn't have to. I mean, there's nothing in the OS that forces that pop-up to have certain wording, and
Mhm.
they can even program the cancel, no, I don't want to do this button to behave as if they clicked OK. So all
That's
the
right.
buttons that they offer you could all still progress the attack, no matter what you say.
That's right.
So,
And
uh,
most of the time, users when they see a push notification on a website, they don't think that it's gonna be able to allow the actor to send them push notifications, even if they aren't in their browser. They have no idea that it's universally changing browser settings, right? So they think it's maybe just a one-time thing. It'll only stay on this website. They could exit out. Nothing bad will happen. But that's just simply not true. But they just don't realize that. Of course, the actors aren't going to let them know that is what's going to happen.
now you mentioned a little bit earlier about looking for source code and things like that while you were hunting to try and find this. But I want to back up a little bit about how did you even know to start looking for this thing? Because it's not like you had customers reporting that, hey, we've got this virus called Omnatour on our system. You were doing some hunting and saw some clues about suspicion and followed it. Can you help us understand, as a researcher and a threat hunter, how did this all come to light for you?
Sure. So Infoblox is uniquely positioned in the threat hunting landscape because we are a DNS first company and we have so much DNS data from so many different customers. So every day we look through DNS queries, so we look for abnormal things, and there are different techniques and tactics that I won't get into here, but we were looking through customer DNS data and we saw something that made our eyes pop. We saw a specific website, omnatour.com, which is where the Omnatour name comes from, the malvertising network, with 45 to 48% on average, with spikes of over 50% of customer visibility. So that's to say, this one website, Omnatour, was in 45 to 48% on average of all of our customers' networks. So that's, this random website. It's not like google.com, it's not AWS, it's some random website that nobody's heard of, and it's everywhere, nearly everywhere to us. That's a huge number.
Yeah,
So
it's
that's what
already
kind
it's
of,
already it's already showing up like in the top 10 and things like that, of the responses and I guess you're looking at that kind of activity just to see, number one, if there's popular sites, even legitimate popular sites, you're going to want to see that, hold it, we don't normally see that popular site that often, and
yeah.
that might raise some suspicion. So you're just noticing that all of a sudden here's a new site that seems to be popular. Let's figure out why.
That's right. And later on, we did some analysis. So we first established like this thing is weird. We need to start looking at it. A little bit later on, we did exactly what you were talking about. We compared this. We wanted to get a sense of, okay, so it's in a lot of customer networks, but that may not mean that it's, showing up a lot in these customer networks. It could just be like one query per each customer network. So we wanted to get an idea over, a 6-month time frame, how popular this one website was compared to things like Zoom, Google, Facebook, all these major websites. Turns out it was, one of the most popular websites in a 6-month period. It's not just like a one query pops up on 50% of our customers' networks. No, it's many hundreds of thousands of queries pop up every day over a 6-month period in many of our customers' networks. So that's, a warning sign. That's a red flag. So we use that DNS data to have that initial discovery. And then we utilize the fact we wanted to understand, then we know how popular it is. How is it so popular? And we had a hunch that it came down to WordPress cross-site scripting, because one of our other threat researchers, Chris Kim, he published a few months ago a paper, a cyber threat advisory, about another actor that had very similar techniques called Vextrio. That's mainly a DDGA campaign. I highly recommend everyone else to check out that cyber threat advisory about Vextrio, because it's a very similar chain of attack. So knowing that we had, one threat researcher looking into WordPress vulnerabilities and cross-site scripting and what you could do with hundreds of thousands of infected WordPress sites, that kind of said, okay, well, maybe this is the same thing. It's an easy way to get a lot of visibility across the web. So we started looking into WordPress vulnerabilities. Ended up that was the case too.
Okay, I want to chime in here real quick, because you mentioned
Sure.
the Vextrio cyber advisory. I'd mentioned yours earlier. So for our listeners, I just want them to know that these cyber advisories are publicly accessible. They're not behind a gate wall or anything like that. And if you want to look at them, you can go to the Infoblox website, go to the blogs, and look under. There's several blogs. Some are business and product, but there's one called Cyber Threat Intelligence. You look under there, you'll find all the different advisories and stuff that we have there. So if you want to take a look at those, because I know you were talking about doing that analysis, and something, of course, you can't do on a podcast here is share a graph. And you guys actually charted it out, and that was in your advisory. I really liked a lot of the charts and graphs and diagrams that you put in there. So I want to make sure our audience knows that the Vextrio, the Omnatour, and several others that we may end up talking about more as we go through here. They were all connected, and there are separate advisories with a lot of details on them for anybody who wants to go into that. But to move this on more, I want to talk a little bit about the infrastructure, because I mentioned in my introduction, one of the first things they have to do is they have to build this massive infrastructure for the malvertising to work, because they just set it up with one site. It becomes pretty obvious real quick. And as it was, you were able to flag omnatour.com as being a common thread. And if they'd been a little trickier, maybe it would have been harder to find. But you were saying that there were a lot of domains, though. There were 9,000, almost 10,000 domains in this thing.
Yeah, almost 10,000.
And they were all around like 2 IP addresses.
No, not 2 IP addresses. So 2 IP networks.
Oh, 2 IP networks.
Yeah. So 2 IP networks. There were, of those nearly 10,000 domains, they were spread out over only 170 IP addresses on 2 IP networks, which is still, for over, or like nearly 10,000 domains, only 170 IP addresses is a small amount. And it's a clear indication that this actor, whoever they are, specifically set up this infrastructure for these domains. Many domains, few IP addresses, they know that they just need a few IP addresses to spin up as many domains, host as many domains as possible.
Now, you mentioned that so the 2 domains, though, I believe in the advisory, it mentions like one of them is based in Cyprus and one in Panama. I mean, this is like opposite ends of the world.
So when you talk about, we were talking about like these legitimate advertising companies that sometimes malicious actors will use, they were hosted in Cyprus. They were based in Cyprus, this company. Panama Names is the domain registrar that these third actors use to register their domains. But Panama Names, even though it's got Panama, the country, in the name, it's actually also based in Cyprus, right? So it's a bit confusing, but these 2 companies, you got the registrar and you have the ad tech company, the advertising company. They're both in Cyprus.
I think Panama Names is just another attempt at evasion. I'm going to write that off as a malware tactic.
That's right.
Use companies whose names sound like they're from different parts of the world.
Yeah.
And then the top level domains, these weren't all like .com. I noticed they were .com, .net, and .org, which most people are familiar with. These are pretty much international. And then there was .co.uk. So a lot of this seems to have been around Europe as far as the infrastructure seems to have been set up around Europe a lot.
That's right. So when we talk about the two IP networks, the hosting providers, the people that provide, the companies that provide the infrastructure for these IP networks, they were based in the Netherlands and in Great Britain. So it does seem to be, I mean, the World Wide Web, it's got the world in the name. It's a pretty worldly thing, but yes, a lot of the infrastructure is based in Europe itself.
Yeah, and I get a kick out of these, particularly at that aspect, because they start sounding like a spy novel or a spy movie where, because it's not, I mean, we talk about a threat actor, but we talk about an actor, it's typically a group of individuals. And, there's one expert in one country and another expert, and they may have never even met, but, they just network to put these things together. It starts looking like a spy novel. I do remember one about a Chinese credit card theft ring that contracted with a Canadian who wrote the malware, but to build the delivery mechanism, he was working with an ex-KGB agent who was living in Morocco.
It
This is
does sound
like
like a spy
25
novel.
years ago. These are the kinds of things that it's actually a lot more common than people understand. Now we are running a little bit low on time, but one thing I also want to point out is that again, not only the international, but these guys are using some of the latest stuff. Like they were doing stuff on Amazon web servers. The you mentioned in the cyber advisory that the threat actor was using Route 53, which is a DNS security tool of all things.
Mhm.
Um, they just use so many components. This wasn't as simple as, hey, we're going to have a server, we'll put out ads, have people go to that server, and then we'll deliver them the bad stuff. It is much more complex, which makes it even more amazing that not only did you find this thing, but you were able to then follow that lead and detect all of these different components. Um, Now, there was a new tool, though, that you used called InfoRanks. And that's something that, because Alexa used to be the thing to compare and see how popular different websites was, but that's been shut down and, being closeted up. And so your company Infoblox created this thing called InfoRanks, which kind of takes that place. How did you use that?
So that goes back to we wanted to understand just how popular these domains were. So as I mentioned, we were looking to see if this domain omnatour.com, just how popular was it? Turns out, we plotted it against InfoRanks, which, like you said, it could be used in sort of an Alexa fashion. Um, Turns out we found that Omnitour is like one of the top 10 most popular domains in our customer networks um, over like a 6-month period. So we just used InfoRanks as a way to establish like these ground truths as a way to compare the popularity, so to speak, of this one domain, Omnitour.
And I want to also point out for the customers that your network of customers, I mean, Infoblox is in like over half of all the Fortune 5,000. I mean, these are big companies. So we're talking hundreds of thousands of users, um, sometimes in a single company. So this is a lot of traffic that you're able to pull from. Um, Unfortunately, again, like I mentioned earlier, we're kind of running out of time. This thing did a lot of stuff. I mean, you mentioned the C2 aspect where it was using that cross-site scripting that it did to move things around. And a lot of this, I think, was possible again because of the WordPress network. Um, WordPress, for those who don't use it, is so common, but it's used by common people who don't have a clue about security. They don't update it, they don't patch it. I remember a study done only 2-3 years ago that found that 80%, it was like 82, 83%. So I'm going to round down to be safe here, retain some sort of journalistic credibility. But like 80% of the sites that they were able to access and survey were at least 2 years behind on updates. And so these exploits that, the threat actors were taking advantage of, they knew not only were, I mean, it wasn't like 0 day. This stuff has been around for a long time because they just don't patch. And so sometimes the threat's not because you're not patching, it's because the services you use are not patching. This is that supply chain thing in an aspect a lot of people don't think of.
Mhm. Absolutely.
Now, the last thing I did want to point out, you mentioned the obfuscation. There was a mention of the Caesar cipher being used in this. What was that for?
That's right. So the threat actors, they used the Caesar cipher to obfuscate their own source code. So when you actually, this is again the remote adware script that's loaded in, and then everything, all the magic happens there. Heavily obfuscated, but it's using the Caesar cipher, so it's pretty easy for me to figure out and decode that. But what it prevents, at least like makes you do a double take. It slows you down a little bit because the source code, the adware scripts, all the magic happens. You're trying to find more hard-coded domains or IPs that you can then pivot off of, and it looks like a jumbled mess. But in the end, it's the Caesar cipher. It's been around for thousands of years. It's very easy. So they probably should have picked something a bit stronger if they wanted to evade a bit easier.
There you
Yep.
go. Threat actors, there's some advice from a hunter on what you can do to make his job harder.
I
But,
welcome challenges. Give it to me.
well, there is a ton more I'd love to get into. Uh, in the blog, you talk about how you did some Google dorking to find certain things. I wanted to get a definition of what dorking was. You also were able to align a lot of this stuff with the MITRE attack method. There's so much more we could go, but I'm just going to leave that with our listeners that they can go check out the threat advisory that you put together that has a ton of those kinds of details. But wow. Chance, I just want to thank you for taking the time out from your threat hunting to be with us today.
Yeah, thank you, Bob. The pleasure's all mine.
And I want to thank all of our viewers and listeners for their time as well. Join us next time as we continue our efforts to help you stay on top of cybersecurity, ahead of cyber risks on Threat Talk.